Alright, in this question, I'm going to be looking at the cumulative frequency curve. And this starts by saying the table below shows the frequency distribution of the marks obtained by 100 students in a test. So the table is showing the marks obtained by 100 students in a test. A. Complete the cumulative frequency table to represent the data. Complete the cumulative frequency table to represent the data. Alright, first thing I would point out is that n is equal to the sum of the frequency. Everybody should know that, and this is what? 100. How many students did the exam? We're told that the table is showing data from what? From 100 students. So n is the sum of what frequency? So again, this is showing you that the number of students here is the frequency. Now we're asked to complete the cumulative frequency table. Now cumulative frequency, to get that, what you're going to do is that you're going to add the frequency as you go down. So let's add. This is going to be 4 plus 6. At this level it is what? 10. Then 10 plus 2, 22. 22 plus 20, 42. 42 plus 26 is 68. 68 plus 16, what is this? 84? 84. 84 plus 11 is 95. And 95 plus 5 is 100.
10 plus 2 not 12. Then you can play that.
Should have been 12. Alright, are you ready? What else about it? So, there are a total of 100 students. So if we're adding the frequency as we go down, here is where we get more what? Or 100 what students. Next thing, we're told, using a scale of 2 centimeters to represent 5 marks on the horizontal axis, and 1 centimeter to represent 5 students on the vertical axis, draw the cumulative frequency curve for the data. We're to draw the cumulative frequency curve for the data. Alright, you see a cumulative frequency curve, it's a curve that looks something like this. No, this does spiral from. The cumulative frequency curve looks something like this. Alright. Alright. Now, down here is the upper class boundary, and over here is the cumulative frequency. Over here says the cumulative frequency. Alright, up here is n, at the very top is n, which is the number of values. In the middle, it's n over 2, which is half. And if you go over here and come down, n rate at n over 2, n rate in the graph, you're going to come down. The value here is what? Q2, and Q2 is the median. The value there is Q2, and Q2 is the median. So the cumulative frequency curve over here is cumulative frequency. Down here is the what? Upper class boundary. At the extreme top of your graph is n. In the middle, it's n over 2. At n over 2, if you draw a straight line across, n where you touch the curve, you come down. The value down here is Q2, and Q2 is the median. Alright, so I need upper class boundaries. Just remind you about some things. So let's put in class boundaries. Alright, so if you all remember, we're going to add 0.5 to the upper boundary and take away 0.5 from the lower boundary. So this is 5.5 and this is 0.5. 5.5, 10.5, 10.5, 15.5, 15.5, 20.5, 20.5, 25.5, 25.5, 30.5, 30.5, 35.5, 35.5, and 40.5. This is the lower class boundary, and over here is the upper class boundary. Alright? How do we get the class boundaries? We add 0.5 to the upper. We add 0.5 to the upper limit and take away 0.5 from the lower limit. Alright? That's how I get our boundaries. There are some other things, well, I mentioned in previous videos, for example, like the class size or class width would be equal to the upper class boundary minus the lower class boundary. And we can use any group in order to do it. Any group will do it. We could use this group. This is 20.5 upper minus what? 15.5 lower. This is what? 5 marks. So the class width would be what? 5 marks. How do we get class width or the class size? The class width or the class size is the upper class boundary minus the lower class boundary for any of the what? Classes. Alright? So the values I need for my cumulative frequency are upper class boundary and cumulative frequency. So these are my values: 5.5, 4, 10.5, 10. Uh-huh. 15.5, 15.5, 22. 20.5, 42. 25.5, 68. 30.5, 84. 35.5, 95. And 40.5, 100. Alright, these are the upper class boundary, and this is the cumulative frequency. Those are the values you need to plot to get your cumulative frequency curve. Let's draw our L-axis. Vertical, horizontal. The scale at the bottom is 2 centimeters to 5 marks. The scale at the bottom is 2 centimeters to 5 marks. So every 2 centimeters, the number goes up by 5. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. Let's see if we can move. And this is the upper class boundary. Alright, which is still talking about the marks. Alright, so the scale on the horizontal axis is 2 centimeters to 5 units. Every 2 centimeter, the number goes up by 5. On the vertical axis, it's 1 centimeter to 5 students. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. 100 students. It's 5 centimeters to 1 centimeter to 5 students. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. And over here is where you have your cumulative frequency, which is students. Alright? Alright. So alright. And over here we have what? 4. 10, 22. Then we have 42. We have 68. We have 84. We have 95 and 100. Now let me ask again, one more time. What is the size of each minor division on the horizontal axis? The little division here on the horizontal axis.
10.
No, what is the size of each minor division? 0.5. Each minor division down here says 0.5. What about the vertical axis? What is the size of each minor division? Minor division. These little strokes here in the middle. What is the size of each? This is, each of them is 1. Each of them is 1. So each stroke over here says representing 1 student. Alright. First point, 5.5, 4. Down here, 5.5 will come immediately after 5. So 5.5 corresponds to 4, 0, 1, 2, 3, 4. That's here. Then we have what? 10.5 corresponding to 10. 10.5 comes immediately after 10. And that corresponds with 10. That's here. Then 15.5 corresponds with 22. Immediately after 15. Then 20, 21, 22. On the vertical axis, each minor division is 1 student. Alright, 20.5 corresponds to 42. 20.5 comes immediately after 20. And that corresponds to 42. 25.5 corresponds to 68. That's immediately after 25. And that corresponds with 68. 65, 66, 67, 68, 68.
What are the doing?
This one said. Then 30.5 corresponds to 84. 30.5 corresponds with 84, just below 85. 35.5 corresponds to 95. 35.5 is immediately after 35, corresponds with 95. Lastly, 40.5, which corresponds with 100. Alright. I am thinking, based on the progression of everything, I'm thinking I actually started at 0.5. Since everybody else is just up to 5, just up to 10, you understand? So I'm going to put this as just after what? 0. Alright? Alright, and so it's a curve, so it must be done by what? Freehand. Alright, and this is your cumulative frequency curve. This is your cumulative frequency curve, or OGAD. OGAD is the name of it. Alright, let us see what else it asks us to do. So we draw the graph. What else do they do? C that says CI. From the cumulative frequency curve, determine the number of students who score at least 24 marks on the test. Now they're asking us to determine the number of students who score at least 24 marks on the test. I'm going to erase these lines because I don't want it to confuse anything. I erase most of them. I don't want it to confuse anything, so I'm removing them. On your graph sheet, you would not have these lines because the only reason I'm drawing, I drew the lines is because I have no lines on the board. Alright, if I had lines, I would not have drawn them either. Alright, so now, this is my cumulative frequency curve. Every point on this curve represents a student and his mark. Every point on this curve represents a student and his mark. So here, the 5th student, he scored probably around 4 on the test. You understand? Every point on the curve represents a student and his mark. That's a good time. So, are you listening? The first thing we need to do is to find out who scored 24 on the test. Well, the marks are down here, don't it? So let's identify where 24 is. Well, 20, 20.5, 21, 21.5, 22, 22.5, 23, 23.5, 24. So at 24, I'm going to go up. At 24, I go up. Then I'm going to come across. Alright, so based on my graph, which is probably going to give a different answer than what your graph, this is saying that the 60th student, his mark on the test was what? 24 marks. This is what? 24 marks. The 60th student, his mark on the test was what? 24. Everybody above him scored what? More than what? 24. And everybody below him scored what? Less than 24. Here's what the question was asked. The question that was asked is, From the cumulative frequency curve, determine the number of students who score at least 24 marks on the test. So CI, number students marks greater than CI, the what? Number of students with marks greater than or equal to 24. Well, let's find that out. Alright? There are 100 students here. The 68 students, his mark on the test was what? 24. Everybody above him scored what? More than 24. Or I should have said this. At least is an inequality term and it means greater than or equal to. At least is an inequality term and it means greater than or equal to. So if we want the number of students who score at least 24 on the test, what I want is the number of students who score what? 24 or more marks on the test. Ladies and gentlemen, this is equal to 100 minus 60. I have what? 40 students. How many students sat the test? How many students sat the test? 100. Alright? This is the mark of the what? Of the 68 students. Everybody above him score what? More than, you understand? And everybody below him score what? Less than what? Fine. His score is what? 24. So the total number of students who score what? 24 or more marks is 100 minus 60, which is what? 40 students. His score was what? 24. And the 39 students above him score what? More than 24. So the number of students who scored 24 or more is 40 students. Last question. Show by drawing lines on your graph how you obtain your answer. So actually this was the last question. And all they are showing is they asked us to do show by drawing lines on the graph how we obtain the answer, which we have what? Have done. This is cumulative frequency curve.